Hello, my name is John Nash, and I am the Vice President of Marketing for Visible Systems. In this presentation, we're going to cover the evolution of software engineering methods, the introduction of software engineering tools, the outgrowth of CASE, which is computer-aided software engineering, promising technology, and the future of software engineering. In a recent article written by Georgia Swan from Computer World in 2009, she said, "There are more than 200 billion lines of COBOL code in existence. COBOL powers almost all global ATM transactions and runs 3/4 of all of the world's business applications." This is a software engineering timeline. It shows that in the 1950s, hardware engineering methods were introduced. It shows in the 1960s that software began to emerge as a craft. It shows that in the 70s and 80s, structured methods showed up in the marketplace. In the 1960s, software crafting, or spaghetti code, code and fix, and debugging took place. At that time, there were limited skills. In the 1970s, the waterfall process, or the systems development lifecycle approach, showed up in the marketplace with structured methods, formal methods, and domain understanding. In the 1980s, it was reusability, object-oriented methods, standards, maturity models, software factories, business 4GLs, CASE, user programming, and productivity. From the time that hardware engineering methods were put in place, there was a 25-year span of time before software engineering methods and techniques took root. The first tools to appear to address software engineering were computer-aided software engineering tools in the mid-1980s. Software engineering in the 1990s evolved into enterprise integration, agile methods, domain-specific software architectures, open source development, but they had lack of scalability. In the 2000s, agility and value showed up in the marketplace. Integrated systems and software engineering, hybrid agile, plan-driven methods, service-oriented architectures, model-driven development. Structured methods were inspired by Dijkstra. He said, "We now take the position that it is not only the programmer's task to produce a correct program, but also to demonstrate its correctness in a convincing manner. Then the above remarks have a profound influence on the programmer's activity. The object he has to produce must be usefully structured. In what follows, it will become apparent that the program correctness is not my only concern. Programmer adaptability or manageability will be another." This was written in 1967. CASE is computer-aided software engineering. It is the scientific application of tools and methods to a software system. The result of using CASE tools for systems development results in high-quality, defect-free, and maintainable software products. CASE also refers to the development of information systems with automated tools for the software development process. CASE tools. In 1987, an article was written in InfoWorld called Software Design Packages Coming Into Their Own. And Ed Warner said, like the cobbler's children, software designers until recently had little software of their own. Instead, they worked with paper, flowcharts, pencils, and templates instead of the tools of the technology they developed. These so-called computer-aided software engineering case packages let the systems analyst map data relationships on screen for later reference and documentation and to follow when coding. Key case approaches. There's the traditional modeling, or the SDLC, the Systems Development Lifecycle Approach, which includes data flow diagrams, structure charts, entity relationship diagramming, state transition diagramming. Then there's object-oriented analysis and design, which includes the Unified Modeling Language, or UML. There's Agile development, which includes XP and SCRUM. And there's business process modeling, which is the graphic notation, which is called business process modeling notation. Traditional modeling through the SDLC. Complementary software development methods to the systems development lifecycle are software prototyping, joint applications design, rapid application development, open source development, end user development, object-oriented programming, and extreme programming. And it uses a system of systems planning, systems analysis, systems design, systems implementation, and systems support. Some of the advantages to the SDLC approach are control, development and design standards, the ability to manage large projects. It has many detailed steps, detailed documentation, resilient to staffing changes, and it's easy to maintain. Some of the disadvantages are more development time is required to do it, it's more costly to implement, user input can be insufficient, it can be difficult to estimate development costs, and it's rigid and hard to adhere to. Object-oriented analysis and design is one of the techniques used. Object-oriented analysis and design is a software engineering approach that models a system as a group of interacting objects. Various models can be created to show the static structure, dynamic behavior, and runtime development of these collaborating objects. There are a number of notations for representing these models, the most prominent being the Unified Modeling Language, or UML. Object-oriented analysis applies to object modeling techniques to analyze the functional requirements for a system. Object-oriented design elaborates the analysis models to produce implementation specifications. Object-oriented analysis focuses on what the system does. Object-oriented design focuses on how the system does it. Some of the advantages and disadvantages of object-oriented design, analysis and design. The advantages are it is said to offer a smoother transition from structured analysis to structured design. It removes the emphasis on functions for structuring the analysis. Object orientation is more coherent, appealing to the human cognition. it has an improved reuse of components and a reduction of development risks. Some of the disadvantages include that the objects emphasize static modeling, and it's unclear whether model primitives really need to be modeled. And the primitives refer to objects, services, and relationships. There is a strong focus on design rather than problem analysis. Problems implementing the legacy code. There are higher startup costs and questions of performance. Then there's the Agile framework. Agile software development methods were developed to rapidly develop reliable software that meets user needs. The strong focus on iterative improvement in the engineering process neglects questions about how other important disciplines fit in and how to apply Agile methods in larger organizations. It is uncertain how the role of interaction, user interface design, and usability impact Agile teams. To compare Agile and the SDLC has some advantages. It's a sequential model. The SDLC is a more predictive methodology. The SDLC requires substantial integration and testing towards the end of the life cycle. Customer involved at entry and exit points on each phase of the development life cycle. The Agile framework is rapid and iterative. Agile methods model in small increments, producing completely developed and tested features in weeks or months. Agile delivers business value early and continually, adding new functionality over the life of the project. And the customer is part of the development team. Business process modeling. Business process models are models of one or more business process. They define ways in which operations are carried out to accomplish the intended objectives of an organization. BPM consists of standards and technologies for the design, execution, and administration of business processes. Business process modeling using BPM notation or BPMN is made using simple diagrams with a small set of graphical elements. This makes it easy for business users as well as developers to understand the flow and the process. When an organization adopts BPM, it is compelled to formalize its business processes. Some of the advantages of business process modeling are that it reduces downtime between activities. It supports process parallelism so that independent sequences can be performed concurrently and independently, and increase productivity with less people, which means more work done faster, and the ability to convert BPMN models into executable environments. Some of the disadvantages include potential confusion in sharing BPM or BPMN models, supporting routine work, support for knowledge work, and it does not include data models, organizational structures, or functional breakdowns. Some newer terms for modeling are model-driven engineering. Model-driven engineering is a software development methodology focusing on creating models or abstractions more closely aligned to a specific domain concept. The goal of MDE is to increase productivity by maximizing compatibility between systems and simplifying design, and promoting communication between team members. Model-driven development, another new term, is an approach to software development where extensive models are created before the code is written. Case, the quiet revolution. Automated case modeling tools have succeeded in solving key productivity problems over the past decade. Today, modeling tools should be part of every software developer or designer's toolkit. Case tools make analysts, programmers, and developers more effective. They offer computer assistance to software development. They make documentation more reliable. They identify errors early in the development process. They make maintenance easier and less labor-intensive. They reduce development costs and speed up development. And they preserve systems as reusable intellectual property. The outgrowth of CASE. CASE has spawned a variety of new technologies, including enterprise architecture, agile development, model-driven development and model-driven engineering, model-driven architecture, business process modeling or business process modeling notation, database administration, code generation, traditional modeling including the systems development lifecycle approach, data flow diagrams, structure charts, entity relationship diagrams, and state transition diagrams, object-oriented analysis, object-oriented design, which include UML modeling, service-oriented architectures, application lifecycle management, and change and configuration management. Standards. An organization called OMG was founded in 1989, which stands for Object Management Group, which is a consortium that was originally aimed at setting standards for distributed object-oriented systems. Today, it is focused on modeling programs, systems, and business processes, and model-based standards. OMG promotes various languages and protocols, including UML, which is the Unified Modeling Language, MDA, which is Model-Driven Architecture, and BPMN, which is Business Process Modeling Notation. Software engineering is fragmented. At present, the market for software engineering tools is fragmented because a number of incompatible host environments. No single solution can be applicable to the construction of software for all applicable domains. This was written in 1987 by Haberman and Montanari, and this is still true today. Many case vendors have come and gone from the market in the last 20 years. The industry has experienced a period of consolidation, resulting in disparate tools sharing the same name, incompatible repositories requiring translation, different user interfaces, and different terminology. The market's direction will include incremental improvements in the methodologies, best-of-breed niche solutions, product suite solutions, and semi-integrated modeling tool suites. Some of the constraints include interoperability limitations, sharing of models without data loss, and insufficient support for collaborative development. Some of the promising technologies include Business Process Modeling Notation, or BPMN, which is a graphic modeling notation for specifying business processes in a workflow. Business Process Execution Language, or BPEL, for web services, is an XML-based execution language for standardizing business processes in a distributed or grid computing environment. Object Constraint Language is a declarative language used to describe the rules that apply to the Unified Modeling Language, or UML models. Domain-Specific Language, or DSL, special purpose programming languages dedicated to a particular problem, technique, or solution domain. Systems are becoming more complex and will require highly integrated and knowledgeable development teams to develop successful solutions. A recent quote said, "The development of large-scale software has reached the point that it is no longer possible for an individual to grasp its size and complexity. This has necessitated, 1. The use of computer-aided software engineering case tools, and 2. Carrying out a software project in teams, both of which require dedicated collaboration." And this is from the Handbook of Research on Social Interaction, Technologies and Collaborations, Concepts and Trends by Tatiana Dumova and Richard Fiordo in 2009. The future of software engineering. We are near the point of deriving code automatically using point-and-click logic generation directly from process models designed by business experts. Clive Finkelstein. Mr. Finkelstein, in his comments, is referring to the generation of BPEL code from BPMN process model diagrams. The next decade will focus on global integration, global connectivity, distributed environments, infrastructure environments, enterprise architecture, collaborative methods, and system building by users. The opportunity for success. The greatest potential is to draw on business expertise of users to generate executable code automatically. By Clive Finkelstein. And this is about analysis and design. Hundreds of billions of lines of legacy code programs have been developed over the decades. A very small percentage of this code is well documented or understood. Millions of new programs will be written in the next decade in a variety of new languages that will suffer from the same deficiencies. Businesses need to focus on strategic directions for their future with reusable business processes and sharing of integrated data. This is so business processes and decisions can be implemented once and shared automatically throughout the organization. When the business needs change, those changes can be made rapidly to adjust to their competitive environment as needed. Rather than waiting years for changes in traditionally developed spaghetti code systems, today we have significant technology, BPMN, Business Process Modeling Notation, to do this. Rather than teach programmers to program, we need to teach business people to do analysis and design. This is the reason why analysis and design are key. The only way to design complex systems is through computer-aided software engineering tools. They will allow businesses to harness their business knowledge and capture competitive advantage for success. However, success will be difficult to achieve without collaborative modeling tools. Thank you for taking the time to listen to this presentation, and a special thanks to Clive Finkelstein, Jesus Borrego, Joseph Magid, Ernest Hughes, Ronald Leach, and the staff of Visible Systems.